operation. So the pull-up network consists of two PMOS transistors which are connected in parallel, and the pull-down network consists of two NMOS transistors which are connected in series. So here the top is connected to VDD and the bottom of these two transistors is connected to ground. We are having two inputs A and B and having only one output Y. So coming to the operation of two input CMOS NAND gate, the condition is if either any one of the input is 0, if either any one of the input is 0, the output is 1. When both the inputs are 1, the output is 0. So for two input CMOS NAND gate, either any one of the input is 0, the output is 1. If both inputs are 1, the output is 0. So let us understand how this operation. First, so when you are supplying 0, 0, when you are supplying 0, 0, when it reaches to PMOS transistor, it should be 1, it should be 1. Here we are having 0, 0, but the PMOS transistor should be on and NMOS transistor is off, and the output Y is pulled to VDD since the value of VDD is 1, so that the output is 1. Next, when you are giving the input as 0 and 1. So at that time, this transistor should be on and this transistor should be off. Either any one of the transistor is on means the output Y is pulled to VDD, and so that the final output is also 1. Suppose if you are transmitting 1 and 0. So when you are transmitting 1 and 0, this should be on and this should be off since it is connected to VDD, so that the output is also 1. Suppose if you are connecting both are 0, 0. So if you are connecting both are 0, 0, these two PMOS transistors are off and NMOS transistor should be on. But the NMOS transistor is connected to ground since the ground value is 0, so that the output is 0. So these are the circuit symbols for two input CMOS NAND gate. So here in the similar way, this is the figure of two input CMOS NOR gate. The expression for two input CMOS NOR gate is Y is equal to A plus B whole bar. So as I said previously, so whenever you are having plus operation, at that time the PMOS should be in series and NMOS should be in parallel. So whenever you are performing plus operation, the PMOS should be in series and NMOS should be in parallel. So for the CMOS, the pull-up network is PMOS transistor. So that PMOS transistors are connected in series. The pull-down network consists of NMOS transistor. So the NMOS transistors are connected in series, parallel. So here the condition is when both the inputs are 0, 0, then only the output is 1. If either of the input is 0, the output is 0. The condition for CMOS NOR gate, if both inputs are 0, 0, 0, then only the output is 1. For remaining all other condition, the output is 0. And this is the circuit symbol for CMOS NOR gate. Next, we're going to see 3 input NAND gate. So this is the schematic diagram of an 3 input CMOS NAND gate. So this is the schematic diagram of an 3 input CMOS NAND gate. As I said, the expression for 3 input CMOS NAND gate is Y is equal to A into B into C whole bar. So here the pull-up network consists of PMOS transistors and the pull-down network consists of NMOS transistor. Since it is a dot operation, so that the PMOS transistor should be connected in parallel and the NMOS transistor should be connected in series. So here either any one of the input is 0, either any one of the input is 0, the output is 1. If all the inputs are 1, the output is 0. So you have to remember the condition for 3 input CMOS NAND gate. Either any one of the input is 0, the output is 1. If all the inputs are 1, the output is 0. So this is an operation of 3 input CMOS NAND gate. So next, this is the circuit schematic diagram of 4 input CMOS NOR gate. So 4 input CMOS NOR gate is nothing but A plus B plus C plus D whole bar. So plus operation indicates that the PMOS transistors should be connected in series and the NMOS transistor should be connected in parallel. And here we are having 4 inputs A, B, C and D. Next, we're going to discuss about complementary CMOS. So usually, if you consider a CMOS circuit, the top portion is a PMOS pull-up network and the bottom consists of NMOS pull-down network. The complementary CMOS consists of PMOS pull-up network and NMOS pull-down network. Here, the gates of both transistor are tied together and give as an input, and the drains of two transistor can be given as an output. So here you can see that the complementary CMOS logic gate, the pull-up network constitutes PMOS and the pull-down network constitutes NMOS. So that's why this complementary CMOS, also call it as static CMOS, or we can say that fixed CMOS. The complementary CMOS, we can also call it as static CMOS. Now let us discuss. Here the pull up is PMOS network and pull down is NMOS network. The pull up is PMOS and pull down is NMOS. So coming to this truth table, here pull up is off, which means the PMOS is also off and pull down is also off. This NMOS is also off. Then what is the condition? So if pull down is also off, pull up is also off, then the output is Z. We can call it as float. Suppose if the pull up is on, which means its value is 1, pull down is off, which means it is 0, then this 1 is tied to VDD, so that output is 1 only. Next, if pull down on, which means the NMOS is on and pull up is off. So at that time, the output is 0 because whenever NMOS transistor is on, it is connected to ground. So that's why its value is 0. Next, pull up on, which means the PMOS should be on, and pull down on, both are on. We can call output as X. We can also say that crowbar. So next, we're going to see series and parallel connection. So here you have to remember 4 things. First,